Hey everybody, welcome back for our 16th episode of our AP review series. And for the 2020 year, when this is being created, this is the final episode. So the final look today, because of our shortened exam, is series. And this is, again, only for 2020 because this topic has been shortened for this year's exam. So there's only really 5 key things that I want to look at today that you should be prepared to see on May 12th. So the first is Taylor series. How do we create a Taylor series for a function that we can then use to make an approximation for that function? And this is a formula that you want to be ready for. So the formula is f of c times f prime of c times x minus c to the first plus f double prime of c times x minus c to the second over 2 factorial, and then so on, following that same pattern. Third, nth derivative, nth power or degree over n factorial. So this could show up in a problem where you have to create a Taylor series. So let's say create the third degree Taylor series for f. And let's say within that problem, either these are given to you or you go and find them from a table, from a graph. You create them yourself by taking derivatives by hand. Let's say within that problem, you are given this information. F of 1 is equal to 0. F prime of 1 is equal to 2. F double prime of 1 is equal to -3. And F triple prime of 1 is equal to +4. So from this information, we can build a series about x equals 1, so centered at 1. That's going to be the C for each of these. And I know it's 1 because these are all at 1, and that's usually stated in the problem as well. So our series would be equal to f of c, so f of 1 is 0, plus f prime of c, so 2 times x minus 1, plus, and not plus this time, -3, so it's going to be a -3 times x minus 1 squared over 2 factorial, and then plus 4 times x minus 1 cubed over 3 factorial. And then I'm going to simplify this down, so 0 we don't need. I'll keep it as 2 times x minus 1, minus 3 over 2 times x minus 1 squared, and then plus 4 over 6, so that's 2/3 x minus 1 cubed. And there's our third degree Taylor series. Now from there, the problem could ask you to make an approximation. Maybe it says approximate f of 1.5. And then you'd have to go in and plug 1.5 in for x, and then simplify to make that approximation. Another thing that you might see here would be a scenario where the problem gives you the series, and then you have to backtrack to figure out these values and then utilize them in some way. Okay, so what else? What else this year? Most of the rest of this year centers on whether or not a series converges or diverges. So not a whole lot with power series besides the Taylor formula. So let's begin with P series and harmonic. So any series of the form 1 over n to the p power, or any multiple of that, 2 over n to the p is a P series. This is a P series, and we know that a P series converges when p is greater than 1. And if p is less than or equal to 1, we know that a P series diverges. And remember that when p is 1 over n, this is also referred to as the harmonic series. So that's a very simple test. And if it shows up, it's a quick check for converge or diverge, no comparison this year. So really, we're sticking to the basics. All right, up next, geometric series will be on this year's exam. And remember that a geometric series is any series of the form a number, let's call it r, raised to the nth power, or to the n plus 1 power. But the key is it's a number raised to a power. And if that number, that common ratio, is between -1 and 1, or in other words, the absolute value of r is less than 1, that geometric series will converge. Because it's going to keep multiplying smaller and smaller and smaller, times a half, times a half, times a half, over and over. If r is not inside of this range, it diverges. And we can say, if it converges, so if it converges to a sum of a sub 1 over 1 minus r. A sub 1 would be the first term in that series. So this is something that we'll use. This is unique about the geometric, that we can actually determine the sum that it converges to. So as a quick example problem, just to do this, let's look at the geometric series 1/2 to the nth power. This clearly converges because 1/2 is between -1 and 1. So what does it converge to? Well, the first term, a sub 1, would be 1/2 to the first, so 1/2 over 1 minus 1/2, like this. So this is going to be 1/2 over 1/2. This will converge to a sum of 1. Okay, next up. My numbers right here, that's probably important, right? Number 4, let's look at the alternating series test. If a series is known to alternate of the form -1 to the n times a sub n, if a series is known to alternate, we can show its convergence by looking at 2 simple conditions. The first would be that the limit as n goes to infinity of a sub n is 0. So the sequence of numbers approaches 0. The second thing would be that the nth plus 1 term is less than the nth term. This means that the series is decreasing. It's getting smaller and smaller and approaching 0. If both of these conditions are true, an alternating series converges. Either one is false, the series diverges. So to look at a quick example, let's let a sub n be the sequence of numbers 1, comma, -1/2, comma, 1/3, comma, -1/4, and so on, this way. We can see it's alternating because the signs are flipping. So the series for a sub n would be -1, and I'm going to make it to the n plus 1, so that when I substitute 1 in here, I get 0 power, so it's positive. And then this is just 1 over n, right? It's the alternating harmonic series. So we know the regular harmonic series diverges, but what about its alternating version? So we're going to look at these 2 conditions. First, does the limit as n goes to infinity of 1 over n go to 0? Yes, it does. Second thing, is the nth plus 1 term less than the nth term? Yeah, because n plus 1 is bigger than n, so this would be a smaller fraction. So it passes there, so therefore it converges by the alternating series test. So really easy test to do, really easy to know when to use it because it's an alternating series. Okay, the last one, and I saved this one for last because it's a good backup if you're not sure what to do. So if you're not sure what test to use to check, look at the ratio test. Also very useful with factorials or powers of n that are involved in a fraction, like 2 to the n or something like that within another fraction. So what the ratio test says, if you look at the limit as n goes to infinity of the absolute value of the nth plus 1 term over the nth term, if this is less than 1, it converges. If it's greater than 1, it diverges. If it's equal to 1, the test was inconclusive and you should try something else. So as an example, I want to look at a pretty basic one here. Let's do 2 to the n over n factorial. So when I look at this one, when I set up my ratio, we're going to have 2 to the n plus 1 over n plus 1 factorial divided by 2 to the n over n factorial. These absolute values are important. If the series was alternating, it would get rid of the alternating. If it was negative, it would make it positive. So you're really just looking at what is this term right here doing when you compare. So I'm going to flip over. So 2 to the n plus 1 over n plus 1 factorial times n factorial over 2 to the n. And then we're going to reduce. So begin with the 2. 2 to the n, so this is equal to the limit as n goes to infinity. 2 to the n plus 1 over 2 to the n will reduce to just 2 in the numerator. The power is 1 greater up top. And the n factorial over n plus 1 factorial will go to n plus 1 in the bottom. Remember, n plus 1 factorial is n plus 1 times n minus 1, and so on. N factorial is n times n minus 1, and so on. So everything cancels except for that first term in the factorial, n plus 1. And then as n goes to infinity, this goes to 0. So therefore, this converges by ratio test. All right, guys, a very limited set of info for series this year. Make sure you understand all of it and be prepared for anything that might get asked with it. And be prepared to see it in the context of other problems and have some other ideas from older units. All right, guys, I hope this helps with your 2020 preparation. This year's different. So focus on what's on the exam and really target those things that are challenging for you and make sure you get them on exam day. Let me know if you have any questions. Thanks for watching.